This might look familiar, but I'm not going to speed run through this IXL assignment. I do want to provide you with some examples of word problems that you might see and how I think about them. So let's just talk it through. Start off with this question. Darnell has already taken 4 quizzes during past quarters. So in some schools, instead of semesters, they have quarters. Okay. And he expects to have 5 quizzes during each week of this quarter. Write an equation that shows the relationship between the number of weeks and the total number of quizzes. So let's say semesters, right? Darnell, he's already taken 4 quizzes this semester, and he expects to have 5 quizzes each week, which is a lot of quizzes, each week of this semester. So we need to write an equation that shows the relationship between the number of weeks that he's in school and the number of quizzes that he takes. And it gives you a nice hint here. Write your answer. That B shouldn't be there for sure. It says, write an answer as an equation with Q first, followed by an equals sign. So Q is the number of quizzes. That's what I'm trying to figure out. How many, we don't know how many quizzes total he's taken. I'm trying to figure out how many quizzes will he take. And that's equal to, well, I know that he takes 5 quizzes per week. So maybe it would be helpful to do this before I even start trying to write this equation. What if he's in school for 3 weeks? 3 more weeks, right? 3 more weeks. Well, then we have the 4 quizzes he already took, plus the 5 quizzes he takes week 1. So this is like week 0, right? He's already taken 4 quizzes. Week 0, at the very beginning, he's already taken 4 quizzes. In week 1, he takes 5 quizzes. In week 2, he takes 5 more quizzes. And in week 3, he takes 5 more quizzes. So total, he takes 4 plus 5 plus 5 plus 5. Or you could say this is 4 plus 5 times 3, right? 5 quizzes a week times the 3 weeks. That is equal to, well, 5 plus 5 plus 5, either way you spin it, is 15. 5 times 3 is 15. So he would have taken 19 quizzes. So how can I make that into an equation? Well, the number of quizzes that he takes, let's take this right here, right? The number of quizzes that he takes is equal to 4, the number of quizzes he already took, plus 5, the number of quizzes he takes per week, times however many weeks. And here they're saying that weeks is W. So 4 that you started taking plus 5 times the number of weeks that he spent taking quizzes. So let's try that out. Q equals 4 plus 5W. And you might see it as 5W plus 4, right? That's slope-intercept form. Doesn't have to be in that form, though. Brilliant. Okay, so that's how you might do that type of problem. This problem would be fairly similar. So let's see if we can get, I know that they have some other types of problems. She's already run 23 miles. So let's do one more. Sure, why not? We can do one more example. She's already run 23 miles on her own. She expects to run 7 miles during each track practice. That's a lot of miles. Write an equation that shows the relationship between the number of practices, P, and the total distance that she's run, D. So, again, we know that she started by running 23. So let's say she goes to, 4 practices. So she's already run 23 miles. Again, this is like she's gone to 0 practices. Plus the first practice, I guess you could say that's the first practice. This is like the 0th practice, but whatever. When she hasn't been to any practices, she's run 23 miles. First practice, she runs 7. Second practice, she runs 7. Third practice, she runs 7. Fourth practice, she runs 7. So just like the last one, right? We have 23, how many she's run, plus The number right here, she's run 7 times the number of practices, 4, right? I have 4 7s, so that's 7 times 4. That would be 23 plus 28. Or we would say if she goes to 4 practices, then she will have run 51 miles. That's a lot of miles. Okay, so then making this an equation, D, the distance, is equal to 23 plus 7, which is the number of miles she runs each practice, times P, which is the number of practices that she has been to. So D equals 23 plus 7P. Boom. Okay, let's go up a level, maybe do just a couple more. Okay, Kira, maybe we can come up here. Boom. Go across. Kira already owns 224 hairbands. And additional hairbands are priced at 10 for $1. So I might change up the colors a little bit. With $7 to spend on new hairbands, how many total hairbands can Kira own? Write and solve an equation to find the answer. Okay. She owns 224 hairbands, and additional hairbands are $10 a dollar. She has $7 to spend on new hairbands. How many total hairbands can Kira own? So we're saying before she has bought any hairbands. So this is 0 purchases. On her 0th purchase, before she's purchased anything, she has 224 hairbands, which I don't know if that's a realistic number or not. I don't own any hairbands. I'll be honest. I'll have to ask my wife how many hairbands she thinks she owns. 224 seems like a lot, but I don't know. Maybe it's not. Okay. Additional hairbands are priced at 10 for $1. So if she made one purchase, so if she spent $1, then she'd buy 10 hairbands, right? So this is her first purchase. If she bought another thing of hairbands, right, for another $1, her second purchase would be also 10 hairbands. So let's think of this just like we thought of the last equations, right? The total number of hairbands that Kira has is equal to how many she has at the beginning, 224, plus 10, which is the number she can get with each purchase, times the amount of money she has. I don't know. D, right? The number of purchases she can make. So how many can she purchase here? Well, she has $7 to spend, so she can buy 7 packs of 10 hairbands. So H then equals 224 plus 10 times 7, which is 224 plus 70, or 294. So she can totally, after she spends her $7 on all her hairbands, she could have a total of 294 hairbands. Brilliant. Let's do one more. Okay, and this one's a little bit different, so I like it. There's some kind of crossing over from the last one, not a big deal. Okay, a person can pay $16 for a membership to the Science Museum and then go to the museum for $4 per visit. What is the maximum number of visits a member of the Science Museum, can make for a total cost of $16? So, remember, before they've gone on any visits, 0 visits. 0 visits. Okay. They've paid $16. If they go on one visit, their first visit, well, it's $4 a visit, right? Well, then the second visit would be $4 more, right? So for a total of 16 plus 4 plus 4. And then so on and so forth, right? You just keep going, so on and so forth. Now, what is the maximum number that you can go to for a total cost of $100? So let's try to write our function. The cost is equal to this membership fee plus $4 a visit times the number of visits that you go on. I guess that should have been blue. We'll keep it consistent, people. I'm trying. C equals 16 plus 4V, right? $16 plus 4 times the number of visits. So if we went on 2 visits, it'd be 16 plus 2 times 4, or 8, which would be 24. Okay, now, the total cost, it tells me the total cost. It's a little different. It tells me that the total cost is $104. So then 104 is equal to 16 plus 4 visits, right? Now, let's solve this equation for V and figure out how many visits I can take. If I subtract from 16 from both sides, and I get 88 equals 4V. Divide by 4. 88 divided by 4 is 22. 8 divided by 4 is 2, and 8 divided by 4 is 2. So then, a visitor for $104, you could go to that darn science museum 22 times. I have a neighbor. He's the guy who gave me the microphone. He's the guy who gave me this sweet tablet that I have, right? He's given me a lot of equipment. He loves museums. This kind of deal would be for him, for sure. So let's check it out. 22 visits. Boom, baby. Okay. So there you go. Those are some example problems, hopefully, that help you, I don't know, see the beauty of word problems for linear functions. I think that'll help. Yeah. So until then, I'll see you next time.